Let's get started. Hi everyone, I'm Xiaohang from Virginia Tech. Today I'm going to present the work VizGroup, an AI-assisted event-driven system for real-time collaborative programming learning analytics. So this work is done with my co-authors Sam Wang, Kevin Pu, Xi Chen, and my mentors Yalong Yang and Yan Chen. So I want to start off by talking about real-time data analytics, which is to analyze data as it is generated to provide immediate insights and enable quick decision-making. Various fields benefit from real-time data analytics. In financial services, people analyze stock prices and trade volumes in real time for high-frequency trading, and likewise, in transportation, they analyze traffic patterns to adjust traffic signals and optimize flow. So real-time data analytics is widely used, but today we're going to focus on what kind of role it could play in education and in classroom. Nowadays, large program lectures commonly contain hundreds of students in a classroom. To foster deeper understanding and enhance students' engage with learning, programming instructors often conduct collaborative learning activities. Peer instruction, for example, is an in-class instructional strategy that emphasizes students' active construction of the conceptual understanding with their peers. During peer instruction, students first work individually on a problem, then discuss their code with peers and make modifications. However, these activities may not always yield productive outcomes due to the diversity of students' mental models and their ineffective collaboration. In this case, instructors need a way to oversee students' real-time collaborative learning behaviors at scale where visual analytics could help. Well, most visual analytics tools support offline analysis of previously collected data. They often lack real-time analysis capabilities. Group dynamics and PairUp have explored the effects of real-time collaboration analytics, but they did not adequately address the need to analyze the relationship between group collaboration and learning outcome at scale. Due to the lack of real-time collaborative learning visual analytics systems, we deployed a technology probe to explore the potential informational needs of instructors and the corresponding design challenges. So we conducted an in-lab study with 8 participants who had experience teaching programming courses. From the study, we evaluated the effectiveness of the probe system and also identified several key challenges. We found that though instructors could identify correlation patterns in an offline setting, it is hard for them to discover emerging correlation patterns in real time. Like if they have a question like what happened to groups activity charting, but they stuck in low pass rates of the coding task, to answer they are required to look into students' details, which could take plenty of time. And also, even when desired patterns were identified by instructors, manually tracking identified patterns could also be challenging since instructors have limited bandwidth when checking details of students' behaviors. In addition, different patterns were relevant in different contexts. For example, initially students may be not engaged in the discussion as they're working on the coding task, but the idleness could become an issue once everyone else has submitted their code. So, based on these findings and challenges, we designed and developed the system, VizGroup, so the AI-assisted system that enables programming instructors to easily oversee students' real-time collaborative learning behaviors. To enable instructors to efficiently navigate and analyze collaborative learning dynamics at different levels of granularity, VizGroup has a 3-level view, which displays the information from class-wide overviews to detailed views of individual student performance, allowing seamless transition between different perspectives. With different levels of visualization and more efficient navigation, instructors might be able to identify more patterns, but it's still hard for instructors to pay attention to and keep an eye on all of them. In order to enable instructors to monitor desired patterns and temporal trends in real time, VizGroup empower users with customizable trackers and alerts, which address the overload instructors experience when trying to follow the progress of parallel groups instructor can now easily track different students and groups by simply specifying corresponding metrics. And to avoid compounding instructors' overload with unnecessary interruptions, with utilizing large language models, the system also generates context-aware notification suggestions by analyzing students' historical data. After ranking students or groups based on their issue severity, the system focuses on the top candidates, summarizing and categorizing their data to produce a final suggestion for instructors. And now I will show you how VizGroup can help instructors with a quick demo. So for this example, let's imagine an instructor who wants to view and manage the peer instruction process of his programming lecture. In order to get an overview of the class, they open the VizGroup and start by browsing the 3 levels of view of the visualization. So whether individual and group view are about student pass rate and activity level, and the structure view here is about active members in groups and their conversational topics. As the class progresses, the system will prompt some suggestion of the notification to the instructor based on the student's historical data. After knowing the overall situation of the class, to track students with potential issues, the instructor starts to craft their first alerts by brushing on the visualization. For this case, they want to keep an eye on the students with low pass rates and low activity level. And then they make some adjustments to the range of metrics. After that, the instructor notices a new context-aware suggestion regarding students with low pass rates and off-topic discussion. So by inspecting the explanation of the suggestion and the corresponding area, they become aware of this kind of alerts. They accept the suggestion and keep exploring the patterns of topics in structure view. After noticing the translation of the scatters, the instructor pays attention to groups with no topic and narrow active members. They decide to ask the notification system to keep an eye on those areas and accept the corresponding alert. After setting those 3 alerts, so the instructor can now start to look into other students and groups' details. At some points, those 3 alerts are triggered in order. Now, the instructor can decide on ways to address these issues. Based on the severity of the issue, they can either make a class-wide announcement or send some TA to support. So that's what the system like in the action. And to evaluate the effect of context-aware suggestion, we compare the full system of VizGroup with a version that has the same notification feature, but without the context-aware suggestion. The user can still create notifications to track patterns, while the system no longer provides suggestions. Additionally, we also compared it to a baseline version with no AI and notification components. To ensure the data participant interacted was authentic, we used the real code and peer discussion data captured from a collaborative learning session of a large introductory level university programming courses. And through the evaluation with 12 instructors in an in-lab user study using real data replay, we found that those context-aware suggestions facilitated awareness of unexpected patterns. Meanwhile, VizGroup also helped instructors identify and track patterns while allowing instructors to work in parallel. Participants also reported that VizGroup enabled instructors to be prepared before sending their support. So this is the end of my presentation. Please read our paper for more details, and I'm happy to take any questions.
So thank you very much. Are there any questions from the audience?
Hi, I'm Prerna. I'm a PhD student at MIT. Just a quick question. So I think in your presentation you mentioned that the tool is able to track like low activity levels, like within groups. I'm also curious if it's able to like track equitable contributions within a group. sometimes the activity level could be fairly high, but that could be the case that it's like 2 people participating out of say 4 or 5. Yeah.
Yeah. Like when we design a system, we consider that like there could be like off-topic discussion or like they are just like grading. So when defining this activity level, we excluded those like not task-related conversation. Yeah. So that's how we how those contributions contribute to the activity level.
Okay, thank you very much. Let's thank the speaker.